We begin by answering the question, what are the key components in neural networks? After completing this chapter, you will be able to describe what a multilayer perceptron is, understand how neural network layers work, describe activation functions, and understand how neural networks learn. A multilayer perceptron, or MLP, consists of at least 3 layers of neurons, or nodes: an input layer, a hidden layer, and an output layer. Data is fed forward into the input layer. This image shows one hidden layer. That is the layer in the middle. This basic structure is referred to as a shallow neural network. This image shows 3 hidden layers. This more advanced structure is referred to as a deep neural network because it has more hidden layers. Except for the input nodes, each node is a neuron that uses a nonlinear activation function. You will learn more about activation functions in a later video. What if you had to build an ML application to predict the selling price of a house in Boston, Massachusetts, a city in the United States? The Boston housing dataset is large and complex and contains a large number of features. As a matter of fact, it contains several non-linear relationships. What distinguishes single-layer perceptrons from multiple-layer perceptrons is that MLPs can learn both linear functions and can also learn nonlinear functions and can be used for both regression and classification problems. For example, this is a typical use case for a multi-layer perceptron. If you wanted to predict the selling price of a house, that would be a regression problem. If you wanted to classify the houses on whether or not they had a garage, that would be a classification problem. MLPs also do not require your data to be labeled, while SLPs do. This is because a single-layer perceptron is a supervised learning algorithm, which means that it needs to be trained on data that has already been classified. The labels tell the perceptron what the correct output should be for each input. Without labeled data, the perceptron would not know how to classify new data. It would simply output random values. The multilayer perceptron, which is a type of neural network, can learn the characteristics of the data without labeling. You input the data set, and the neural network learns its patterns, learning how to represent the data with features they extract on their own. So let's summarize some of the characteristics of a multilayer perceptron. It is a feed-forward neural network, and this means that the information flows in a single direction from the input layer to the output layer. It has multiple layers of perceptrons. This allows the MLP to learn more complex relationships between the input and output variables. The perceptrons in each layer are connected to the perceptrons in the next layer. This allows the MLP to learn the dependencies between the input variables. The output of each perceptron is used as the input to the next perceptron. This allows the MLP to learn the relationships between the input and output variables.